Hi, in this lesson, we're going to cover multiplying and dividing rational expressions. I'd like you to recall what you remember from rational numbers and how we multiplied them. If I had a over b times c over d, where a, b, c, and d are numbers, then their product is going to be the numerators multiplied, ac, and the denominators multiplied, bd. So we multiply numerators, we multiply denominators. Now, importantly, if there are any common factors that the numerator and denominator share, you should remove them by dividing first. So in this example, 15 over 6 times 3 over 25, I don't want to write 15 times 3, which is 45. Don't make numbers bigger. Look for opportunities to make them smaller. Consider 15 to be 5 times 3, and 6 to be 3 times 2, and 25, 5 times 5. So what I've done is prime factorized. Now notice how I gathered all of the numerator factors together. 15 has factors, 3 has a factor, but I'm multiplying. So they're really all just grouped together as numerator factors. I see a 5 here, I see a 5 down here, I can divide them out. I see a 3 on the numerator, a 3 on the denominator, I'll divide them out. There's nothing else in common between numerator and denominator, so I'm left with 3 over 10 as a simplified rational number. We're going to do the same thing with rational expressions. Again, I want to emphasize how important it is to factor. When you're unsure of what to do, factor. Things will become clearer. All right, let's look at these. The first one's already factored for us. There's a multiplication, and I got a bunch of factors on the numerator, factors on the denominator. Some of them are polynomial factors, and some of them are just coefficient values. I see the 8 and the 6, and they share a common factor of 2. So let's divide out the 2, neatly put a line through it, and write the remainder. Be careful when you do this. If you're a messy writer and you do lots of cancellations, it will be difficult to see your work. You've got to be tidy about this. Here's an x plus 3 factor, and here's an x plus 3 factor. Numerator to denominator, I'll divide them out. I'm left with a 4 and a 4. They're not going to cancel because they're both on the numerator. This binomial is different than this one, so I think I'm done. I'm going to multiply 4 by 4 to make 16. I have this binomial on the numerator. And the denominator has a 3 times a 3, or a 9, and x plus 1. I can leave it in the factored form. I can expand it. Either one. Both equivalently good. I don't mind which way you do this. Okay? The factored form, in fact, is preferred in many cases because it's more clear to see what reductions are available. You kind of lose that when you expand it out. There's the first one done. Second one, I'd like you to try this. Now this one needs to be factored first. Give it your best effort, pause for the video for a moment, and then come back and rejoin me once you've tried to get your answer and compare it to mine. Okay, now there's one little trick in this problem. A few actually, but depending on how much you remember your factoring. 2x minus 6 numerator has just a common factor of 2. That's all you do there. The denominator is a difference of squares, so you get two binomials. And this denominator over here needs your attention. Look at the 3 minus x. Look at the x minus 3. They're very similar to each other, but their signs are different. What I did was I took this denominator and I factored out the negative 1. So negative x becomes positive x, 3 becomes negative 3, and now these binomial factors are identical, and I can cancel them out. I couldn't have done that before. I've got a common x plus 1 factor, and my remainder then has 2 on the numerator, and an x minus 1 on the denominator, and that minus sign, we normally write that on the numerator. Now you can also write this, positive 2 over 1 minus x. Notice how I changed all of the signs. Negative 2 becomes positive 2. If positive x becomes negative x, and negative 1 becomes positive 1. What I did here was I multiplied everything by negative 1, numerator and denominator. Both forms are equivalent. I don't mind which one you write. Okay, here's a harder one. Again, I'd like you to pause. I want you to do all the factoring you can do, cancel common factors, and then check your answer against mine. Pause now. Okay, I've got it fully factored, and a couple of things occurred to me as I was working this problem that I want to comment on. One, don't work on numerators and denominators separately off to the side because they're complicated and write your work in an inconsistent way. What I want to see from you is that you write your equal signs down the left, everything is vertically aligned, and at every stage all numerator and denominator factors and expressions are complete and equivalent to what's above. Just work neatly and methodically, okay? This is really like 4 problems in one. Term 1 numerator, term 1 denominator, term 2 numerator, term 2 denominator. Each one gets factored. First one is a common factor of 2. I removed that. Then I factored the trinomial. Denominator, difference of squares. Both of these factor into 2 sets of binomials. So on this line right here, now I have it fully factored, and I can remove common factors by dividing them out. These divide out. These divide out. These divide out. And that's it. I'm left with 2 bracket x plus 3 over x minus 4, which could be expanded or left factored. I don't mind. Leave it factored just fine. Okay, one more thing to talk about, and that is dividing rational expressions. Remember that if you have a over b and you're dividing by c over d, you can rewrite it as a over b times d over c, and therefore AD over BC. What we do is we multiply by the reciprocal, and then we treat them the same as we did before. It's the reciprocal of the second term. The C over D becomes the D over C. Okay, here's one more problem to try. I'd like you to do what I just said about division, factor, simplify, and then rejoin me. Okay, step 1, I did not change the first rational expression. I changed divide to multiply, and I wrote the reciprocal. Denominator becomes numerator, numerator becomes denominator. Step 2, factor everything you can see. Step 3, divide out common factors. I've got a 3 here, the 9 becomes a 3. I'm left with an x times an x squared over 3. Those are the essential ideas of multiplying and dividing rational expressions. Good luck on your assignment.